The Internet of Water project is a coalition of many organizations trying to modernize and harmonize data infrastructure in the states, where Colorado is collecting data differently than downstream of them in New Mexico. So it is working on trying to make that data interoperable, like the water that flows through those political boundaries. So today I'm going to be talking about River Runner, which is a tool developed in part with USGS to index and navigate the hydrologic system both in the States and globally. So what is the Hydro Network Link Index? It is a RESTful web service to discover indexed hydrologic information along a stream path. It is a river navigation tool providing geospatial representations of stream flow lines, catchments, basins, and water monitoring locations. And it is also an open source project used and supported by the United States Geological Survey. And how does the NLDI work? So there are many ways to do routing in the same way that we're able to use Google Maps to get from point A to downtown from here. What it relies on is value-added attributes, which are a set of pre-calculated relationships between different segments in a river, and to then allow for navigation. And it also relies on community-contributed features, because more than just an interesting visualization to see what is downstream of you, what is upstream of you, it also allows you to see what locations are downstream of you that are indexed to the NLDI. So some of the most important value-added attributes that we'll be talking about are stream level. And stream level is reliant upon just how many segments is the stream away from flowing out into the river, or into whatever its output basin is. So stream level will equal 1 for all flow lines flowing into the ocean or into a basin that does not flow out. And so then all streams that flow into that flow line are given stream level number 2. So next, we also have hydrologic sequence. Hydrologic sequence uses graph logic to ensure that for every segment of a river flow line, the stream flow line above it will have a higher number. In that way, you can always know where you are in the hydrologic system and whether or not you need to go up or down. And so for hydrologic sequence, this is rendering of the hydrologic sequences between where we are in Prizren all the way out into the ocean. So as you can see, there are many hydrologic sequences, and hydrologic sequences are broken up anytime there is a new river flowing into it. But rivers are much longer than any time there's some inflow. So that's where level path identifiers come in. Level path identifiers are saying this entire stream segment is the same stream, and it is given the identifier of the hydro sequence lowest in that river. So what this looks like is in Prizren, there's actually only 2 full rivers that flow. There is one that flows through Prizren, and then there's one that flows the rest of the way as it goes out into the ocean. And then there is also a terminal path identifier, and this is the hydrologic sequence of the last flow line in any part of the network. So in the entire basin, all river objects will have that exact same number. So what this looks like in Prizren is querying very quickly to be able to see these are all of the flow lines in the basin that are flowing both through Prizren and anywhere else. And there are many more value-added attributes for many other aspects, but those I think are the most important ones to think about as we're getting into this. So what this allows you to do is okay. Sorry. That's all right.
You should connect it.
I can show you this demonstration at the end. But basically what it allows you to do is you can get a Google Earth Mapbox-like exploration of any point in the world, and it feels like you're flying along the river. So this is more of a visualization. So using all of those value-added attributes we just talked about, by inputting any latitude and longitude, you're able to generate the entire river flow path downstream. And then what this does is it then puts that GeoJSON output onto a Mapbox tile layer and then flies along. So I can show you that at the end. But the importance of the NLDI is that it's more than just a visualization, because as interesting as it is to see the entire Amazon River flow path from the start to the finish, or the Nile Basin, or the Yangtze River, there's an infinite number of very cool rivers to fly along. The NLDI is also a service to discover other index information. So this is something that is only currently true in the domestic United States version of the NLDI. But what it allows you to do is start with any NWIS site. So NWIS is the National Water Information System in the States. So you can index, so any feature that has been indexed into the NLDI is given a RESTful endpoint to then be added to a map. So this is the USGS's NWIS site in the middle of the Rio Grande in Texas. But using the NLDI, you can also query for all upstream main flow lines. So this is now a map with only a couple extra lines of text in the URL that shows you the entire upstream main. And the NLDI can show you upstream main, downstream tributaries, and upstream tributaries. So it allows you to see where your water is going, but it also allows you to see other sites that are indexed onto those same systems. So now you'll notice that instead of indexing for the flow lines right here, what we're actually looking at is other NWIS sites that are upstream of that NWIS site that we first looked at. And beyond that, you can also say, actually, I don't want to see the entire basin. I want to see where all flow lines in this basin upstream of me could be coming. And you can start to put that all together and show just the NWIS site, plus the basin, plus all the upstream main path, plus all upstream tributaries of that main path. And then also all water quality portal, which is a separate system run by the United States EPA on water quality monitoring. So now, at a very quick moment, you could have landing pages like this in the United States EPA government, where for any water quality station, you can see what locations are upstream and downstream of me. This is very important, especially when there were things like the East Palestine train explosion in the States, where no one really knew where that waste was going, and they thought it was going to start flowing downstream. This is a very straightforward tool that would allow someone to, starting at whatever point, see what the water quality actually looks like downstream of that. And so the current state of the network linked index in the United States, it's implemented in Java with an open API document introducing a new developer on how to interact and use the data. It can index any data into the NHD plus high resolution, so it does a geometry intersection and then assigns a common identifier that is what the flow path is. So what that allows you to do is anything that has a geospatial representation in the US can be indexed in the same way the water quality portal sites are, in the same way that the National Water Information System sites are. And there are many other aspects that are indexed. So I think there is also census blocks. There are a myriad of other things. And that's kind of where we're starting to get into the future direction. So the NLDI is also currently being rewritten from Java into Python so that it can hopefully be a little bit more understandable and have a longer life. As well, the Open API document is being updated so that it actually enumerates every single data set that has been indexed into the NLDI instead of requiring a developer to know. So now when you open the NLDI Open API document, it will encourage you to look at water quality portal sites, national weather or water information sites. And COM IDs are the flow lines. So what it allows you to do is, really easily explore any data in the United States and then also deploy it yourself. So this is being run by the United States Geological Survey. This is a website that they are planning on continuing on supporting, but for any other data that, independently someone wants to include in the NLDI, they could run their own server and index the data to the NLDI and have it appear in their open API document, allowing for someone to explore upstream and downstream. Furthermore, USGS is also currently working on improving the NLDI to include Alaska, which has really complicated water diversion sites and points, because for the NLDI to work correctly, you need to know exactly what catchment the point is when you start. And that is where it gets a little bit difference between the global NLDI and the United States, or continental United States NLDI. The global NLDI is just showing the hydrologic data downstream without the current capacity to index it. And this is all run through an OGC API process using PyGeo API. So if you input any bounding box or a latitude and longitude or a specific identifier within the world that you would like to look at, you can see the entire downstream path from there. Where this could be extended is by adding the same ability of the continental United States NLDI, which allows you to not only see downstream main stems, but it allows you to see upstream main stems, upstream tributaries, and downstream diversions. These are all pretty important aspects because water does not flow in one linear direction always, and there are so many aspects of what water is feeding into this place, what water is being taken out of this place, and where does it all come from. And then the other side is that the global NLDI is a mix of merit hydro and natural earth, so it does not have quite as the same coverage for naming of all the rivers like the continental United States NLDI does. And part of extending that would be trying to develop and explore a global community of practice who can support and maintain the NLDI and index their data on a global scale. For further reading, there are many sites. So River Runner is for the global and United States. That is the simple tool visualization that shows you a Google Earth-like exploration of any river path anywhere on Earth for the global, and in the United States for the US River Runner. And the intros are just describing what they do and how they exist. And all of this data also exists online freely. So the data that is supporting the continental United States is a USGS published catalog item that anyone can download, just like the global data is. Because really the goal and understanding is that this is not something that can be done alone. This is something that is really best enriched by a community. And that is why the Internet of Water is working on this with the USGS, because water does not flow in the same way that political boundaries do. And it needs to become a coalition of many organizations, of many countries, of many states, if we really want to get ahead of how and where water is moving in the world. So thank you so much. This is some contact information for my team at CGS, which is the organization supporting the Internet of Water. And we look forward to talking to you more.